Let's take one more example. See here, we are going to take a apparatus. Here instead of now earlier experiment we have taken what? Beaker. Here we are taking a test tube and a piece of ice, wire gauze, a burner and a candle. So take some water in a test tube, wrap the piece of ice in a wire gauze, drop it in the test tube. Means in the water we are going to put what? Ice cube. Now what happened? It will sink. It will sink means it will goes down. Now using a test tube holder. See the test tube holder, can you see why we have to use? Otherwise the test tube which is made up of glass, it becomes very hot after certain time of heating passes through it. So we are going to use a test tube holder. Heat upper part of the test tube. Stop heating when the water started boiling. After certain time what happened? The water started boiling. Observe the piece of ice at the bottom. The heat does not reach the bottom even though the upper part is heated. How does this happen? The density of water decreases due to heating. Therefore, it cannot sink and the process of convection does not occur. Now student, here what happened? The volume is low, the area. Now the beaker where the area is bigger one. So even if the water which is boils over there itself, it's not reaches down. And that even that ice which is wrapped, so the heat is not reaches over there, it reaches only at the upper portion. As it is reaches only at the upper portion, no convection current is formed over there. So this is again one more example where the convection currents will not get the convection current. Now let's see the next type of transfer of heat, radiation. Now radiation means what? Here we are not required any medium like a burner or anything light thing. It's get hot automatically. For example, mobile, which we are using nowadays a lot. If you use a mobile for a long period of time, what happen? It get hotted. So that is called as that is the best example of radiation. Or if you touch the bulb or tube light or any other electrical appliances, our hand get burned, it become hotter. So that is what the example of the radiation. Also see the first example here given, sun. Because of the sunlight, the earth gets a sun energy. So these kind of examples are of radiation. Here also the example is given where the flame, and if we hold our hand in front of this flame, we will get the warmness or we get that hotness from that flame. So that is called as a radiation. So what is in case of radiation? We are not required any medium. Now student, let's see wonder of science. You will see such type of camera. That camera is called as a infrared camera. Now infrared camera, where if you click the photos, see you will get the photos this kind. This kind of photos you will specially get it in the dark, when there is a complete darkness, and by using such camera, when you click the photo, we'll get this kind of images. See, here are some examples given. So what happened? What is used over there? A camera has been developed which uses this radiation to make our surrounding visible at night. So here is this transfer of it. This radiation is using over there so that the things are visible to us. Now let's take one more example here. In the apparatus are the two aluminum tins we are going to take. But these two aluminum tins, where one aluminum tin where we have to cover with a black color. Okay, we have to give the black coating, where another one we just have to put it as it is. Both the aluminum tin we have to take it with a water and put it somewhere outside where get a proper sunlight. But after some time, after 2 hours, when we'll take it inside, we'll get that the aluminum tins with a black coating, the water is more hotter than the aluminum tin which is without black color coating. Now why it's happened? Because yes, what is the reason behind it? Because the black color which is absorb the heat more than other container. So this is what in the black color the absorption of the heat is more. So especially when we have a summer season or even in the October, and if we wear a black color clothes, will feel more hotter than any other color, because black color absorb the heat more. So good and bad conductor of heat. We are going to find out the good and bad conductor of heat. So for that, let's take some example. Here are some ingredients we are going to take. A spoon, a copper coil, then the rounder, divisor, pencil, scale. And all these things we are going to put it in the hot water. So student, whatever you are going to do this experiment yourself, and then whatever is your observation that you are going to write down over here. Then after you putting all these stuffs, all the spoon and the coils, rounder in the hot water, what will be the observation that you have to write down this in the table, and then you have to write down that in the rub book. Okay, so what is the inference from it? Some substances are good conductors of heat, while some are bad conductor of heat. Now student, that conduction where we learn that the copper, the strips, the pins on the copper bar which is fall faster than aluminum and stainless steel. So it shows that the copper is the good conductor of heat, where the transfer of heat is more as compared to others. So heat is easily conducted through a copper strip or the spoon or a pot. Okay, but not through plastic and wood. That you will see in that experiment. When you will do it, you will understand that through spoon or through the copper strip, you will see that become a more hotter as compared to plastic and wood, because plastic, wood, thermocol, they are the bad conductor of electricity. They are non-metals, whereas the copper, iron, aluminium, they are the good conductor of electricity. Now we are going to see the expansion and the contraction of a solid substance due to heat. Here even this experiment we are doing usually in the lab, but now this year it is not possible. We are going to take a metal, this kind of metal ring and the metal ball. So in the first, before heating, the ball is easily passes through the ring. But then we have to make it warm, make it hot, that ball, and then we have to see that, we'll observe that that ball will not passes through the ring. So why it will not passes through? Because that ball which get expand after heating. Of course it is a temporary change. Once it is cooled down, once that ball is cooled down, again it will easily pass through that ring. So this is what happen, expansion and the contraction of a solid substance due to heat. Let's take another example, but now it is in the liquid solution. Student, you know that when we boil the milk or water, during the time of boiling, it rises, but after certain times it will again goes down. So student, go through this experiment where it is given to us that the temperature rises, the liquid solution rises, and then once it is cooled down, it is again goes down. So you have to go through this experiment properly, read it and understand it. Also one more experiment in the expansion and the contraction of gases. Again read this, try even at home and see that how the expansion of the gases takes place. So these two, expansion and the contraction of liquid and gases, is a self study for you. Just try it yourself and see how it is happening. Now the last part, we are going to see the thermos flask. It is also called as a De Vii flask because it is discovered by the person, the great scientist. As you all knows about the thermos flask very well. The thermos flask is used for keeping the tea, coffee and milk, etc. So you know that if we keep anything, the hot object will remain hot, whereas the cold object which is remain cold for a long period of time. Why? It's so that the structure is made this way. So see in this picture, it is clearly given whatever is the structure. So this is the double wall flask. Inside the flask there is a double wall. It consists of two glass tubes, one inside the other with a gap between them sealed. The air between the two tubes is removed to create a vacuum. Okay. And the last part, we are going to see the function. So function of the thermos flask. When a hot substance is placed in a thermos flask, the heat going out gets reflected due to shining surface of the inner tube. Hence heat is not radiated. Neither conduction nor convection of the heat occurs because of the vacuum. It's contained that vacuum inside. As a result, heat is not transferred to the outer cooler region and retained inside the long time. Because of this kind of function, whatever is the heat that is remain inside over there, it will not goes out. But student, in case if you are not fixed the lid, then there's a chances that the thermos flask will not function properly. Okay, so student, you have to go through this diagram, see the labeling each part properly and draw in your science notebook. Here is a great scientist who is on 1892 first discovered the thermos flask. Okay, so read the information. Student, here is the end of this lesson. This lesson, lesson number 9 and lesson number 8, both these lessons are for the orals. So you have to read the lesson carefully. Whatever is the objective types question will give it, you have to write down that and understand it. Thank you very much.